All right, so we are live. Okay, so my name is Brian James. I am a senior developer at Map Anything and one of our brand evangelists. I'm also the co-host of a developer live podcast called System.debug, which I'm also going to be broadcasting live during this presentation, so people at home can also walk through the same hands-on training that you guys are going to be going through today. The very first thing that you're going to want to do to follow along with the training is go ahead and go to mapanything.com/hands-on-training. And that'll get you directly to all of the walkthrough instructions and some helpful links as we go through the project today.
Mapanything.com.
You want me to see if I can?
You have to close my eyes.
And once again, once you actually get to the site, you'll be able to follow along on your computer as well.
.com/hands.
Gotcha.
Hands to
If you unhighlight it so it's not blue.
Oh, yeah, totally.
Maybe not. Hands-on-training.
Yeah, I can draw.
Use this charger.
All right. So one of the other things that you're going to want to enable for this is making sure that you have an org that is Lightning enabled and that you've already set up your domain. If you haven't, maybe go ahead and start spinning that up now while we get through like the initial discussion on the schema class itself, just to make sure that when we actually do build our component, it will be able to be usable by an admin. Awesome. All right. So as I said, my name is Brian James. I'm very happy to be here today. It's kind of my first actual session at any of these conferences, so that's really exciting for me. And I want to thank everybody who actually showed up to, cheer me on and join me in it. We are going to be talking about the schema class. I don't know how many people here have worked with it a lot. If you work for an ISV, more than likely it's kind of your bread and butter. The whole purpose behind the schema class is being able to give us access to our metadata for all of our objects, our fields, pretty much anything across the board in Salesforce that isn't our actual data. The schema class can give us availability to use that. And the purpose of that is so that we can build more dynamic pieces of software, especially with Lightning being the big push for Salesforce right now. It's important for developers to be able to make modular components so that they're only doing it once, so they can take it and a admin can use it on their contacts, they can use it on their accounts, they can use it on a custom object or a standard object. But the purpose is so you can spend a lot less time developing the exact same piece of software over and over and over again for different pages, right? You want an admin just to be able on the fly to be able to add something to that. And so that's kind of what we're going to be looking over in the demo today. Is we're taking advantage of the schema class so that we can create a component where it's just basically going to go out on any record you're on. So we'll put it onto an account object record page, and I can show you that now. And what it's going to do is it's going to get the first 10 fields that get returned by the schema class, and it's going to run a query on those. And it's going to then run a query based on those data points across the entire org and all the accounts, and show us what field was there, how many records are matching that field, and what that field value actually was. So it's not really the best use case for a real live situation right now. However, you could enhance this with things like a field set, and using the schema class, you could actually pull down the fields from the field set and run the exact same thing. So your admin could say, no, on my account field set for my account record page, it's going to have these 10 fields. They're the only fields I care about reporting against. Right, so you can really kind of enhance the product that we're going to be creating today on your own. But for the use case, we're just going to pull down the fields and run with those. Also, make sure that I would recommend having Word for whatever component or whatever page that you want to throw this into, so that it actually shows up and works for you. The only thing we're definitely not going over is the test class. So I hope you know how to test. If not, that's another session for another time. All right. So the main focus of this is going to be using the get global describe, the describe s objects, and then field set describes, which you can, or not field set describes, but descriptions. And those things come through this describe s objects. If you're following along, these are links directly to those pages in Salesforce, the documentation, to kind of read more about it and understand more about the actual methods that are available to you in the Schema class. And so I guess really we can just start jumping right in. We're going to need 4 things for this, but well, 3 for our actual demo, and that's going to be an Apex class to handle our logic, an Apex test class, and a JavaScript controller. Now the JavaScript controller is going to come along with a component, so you're not going to actually have to spin that up. That'll be fine for you. And since we are using a Lightning component, we're going to want to make sure once again that you have your domain set up and that it's been deployed to your users. Otherwise, your Lightning component will not show up in the sidebar for the Lightning page builder. So just a, forward looking or something. Anyway. All right, so the first thing we're going to do is we're going to spin up a brand new visual or Apex controller. I've done this 2 or 3 times, so I'm going to have to rename mine. I'm going to be using Aside for this. Aside is a free cloud-based IDE. So if you don't have a favorite one and you just need to do some light work, Aside is definitely a viable option in that case. All right. So all this code can be copied and pasted, and I've definitely done it all already, so it definitely works. The only thing that we're going to need to make sure that we change when you copy and paste the code directly from here is on this initial return, in order to save, we need to change that from a string to a null. That was my bad. I apologize. But we can just go ahead and copy all that and put it right in here, and we'll talk about what this is doing. So the first thing in order to make a Lightning component is we need to make it Aura enabled. All right, that's the first step across the board for any Apex method that you want to call from a Lightning controller is going to need to be Aura enabled, otherwise it won't find it. In our case, it's just going to be returning a string, a single string. And the first thing that we're doing here is actually getting access to a record object. It's passing in 2 parameters. I'm going to get better at this as we go along, so I apologize. But anyway, so the first thing that we're doing is we're going to create a new method called getObjectList. And the purpose of this is we're going to be passing it a record object and a record object ID. Okay, and the purpose of both of those things is so that, one, Lightning can tell us exactly what object that the page is landed on, whether it is an object or not. And that's the first piece of information so that we know which set of data we're going to be dealing with, which object of data we're going to be dealing with. You could also get this information from the record ID, but for the purpose of this demo, we're not going to do that. We are going to pass ourselves the record ID, though, so that we have something to query against for our initial values. And we can do that by simply setting up our schema describe object result. And what this is doing is it's going out and doing global describe on whatever object we've set in our parameters, and it's bringing back all of the metadata information for that. So it's giving me all of the permissions for the current logged in user, whether or not the profile allows me to edit it or make any sort of modifications or even read that specific field. So all that information comes back from the schema class, as well as all the field data. And then you can create a map of that data, which I believe we'll be doing here next. It is. So what we're going to be doing here now is we're actually going to get all of the fields in our. Just want to make sure I didn't skip something. Okay, that's where we were. This one's a little out of place, it looks like. For the sake.
Can you increase the font or the?
Yeah, absolutely.
Thank you.
No problem. All right, so our next step is going to be actually creating a map of all the fields in that object that's going to be getting passed to it. And we're also going to create an empty set for once we've formatted these field names. And you'll see what I mean by that in a second here when we actually go through the process of doing it. You can go ahead and copy that section of code and put it directly underneath the code we've already placed. Is that better? Yeah. Cool. All right. So we're going to need to figure out what our record counts are. Okay. In order to do that, we need to create a map that can hold the actual API name of our field. So as we're looping through and we're getting the data from it, we can match our counts to that field. And that way we're going to be building out what our actual display is going to be coming out of. And that in this case is going to be our record count. Our record count is going to consist of a map, but that map has a string, which is our key. And the value for that initial map is going to be a following map with a string and an object. The reason that we're using an object versus a literal data type or you know, such as a string or a list or a map or anything like that is simply because of the fact that we don't know what we're going to be sending it all the time. With companies like as an ISV, when you're working for like Map Anything or Squid or other ISVs, you really don't know what your users need. Only they do, right? So you can't account for all of it. So you need to use more generic things such as object rather than an actual list or map, depending on what you're trying to do. A lot of times, obviously, if you really know that this is going to be the data that's getting returned, you would use that data type. But for, once again, the sake of this object, we don't really know. So for the time being, we're going to leave it as an object. And then the next thing that we're going to do is be creating our like kind query string. And what that's going to be is a list of all the fields that we're going to be querying for once we've determined what those fields are. We can just go ahead and copy that, and we're going to put it directly under our field names. It drives me crazy. All right. So the next thing that we're going to be doing is determining which of our fields need to be formatted and which don't. And by that, I mean the return for when it comes back from actually the Salesforce database, because we want it to be displayed in a way that is readable to our users. And we're not going to be using things like Apex output fields and stuff that can automatically determine the data type of the data when you're returning an account object record or something like that. We don't know what that's going to be. So we're going to let our query actually handle that with our SOQL query using the aliases for format. Okay, so that way we can determine if we're going to have something like a currency field, a double, a Boolean, integer, date, datetime. All those fields need to be formatted to represent the user's locale, to represent, you know, their time zone, everything like that, or even, you know, if it's got decimal places and commas, it's what people want to see. You know, a currency, you're going to want to see your I used to say dollar sign. I really don't know what the term is, I guess. But nonetheless, these are things that you're going to want to format versus things like strings. You're never going to need to format those because that data is just exactly as the user entered it and it was supposed to be. So we'll go ahead and we're going to add that in right now. And this way, when we're adding this, what this allows us to do is instead of running a big check against, you know, is it this or this or this or this or this? Instead, we can just simply, because it's a set, we can call a contains on it, and we can just simply determine, hey, does that set contain this keyword? If it does, I need to do this thing. If it doesn't, keep moving on. But we're not looping over and running 8 different conditionals in order to determine whether or not it needs to do that. So it just kind of streamlines the process and makes it a little bit faster on the actual resources that we're using here. Okay, so according to this, all of our groundwork has been pretty much laid, right? We have all our methods and our variables, and we're about to start getting more into the actual building of our software. So for this is where some developers hate me, and I respect that because we're going to do for loops and for loops. You know what? I'm a rebel. I just don't care. So just don't tell my boss. All right. So for this current record query, what we've done is I skipped a part. Wow. Here it is. All right, cool. Don't want to miss this. Prior to the for loop, what we're going to do is create our actual current record query. And in order to do that, we are going to select, and we're going to do a string join on our list of field names. Now, our field names is actually what we did is we took our original global describe of our record objects metadata, and we went out and we got the key set to the map of fields. The map of fields is basically just all the information for every single field on the account object, and we just did a .key set because we don't want to have to loop through all the keys and pull those out individually. We'd rather just get the key set. So it's the same command you would do if you were going to loop over a map, but in this case we're just kind of instantiating a list and pushing all of this information into it right away, making it a lot easier available to us. And we're actually doing it as a set, obviously, because we only want unique values. And then we're going to take that set, convert it to a list, and join all of them in a string on commas. And that's going to build out our SOQL query, right? So that would be, if you were to do a system.debug on that with the from record object, which is the variable we passed in, and the ID equal to the record ID that we passed in, you're going to see a very common looking select statement, something that would make you feel very comfortable using, copying and pasting it directly into your developer console's query editor or whatever have you. So that's one of the nice things, is that we've been able to do that, pull all of that information in, and we're about to query for it. Then what we're going to do is we're going to loop over the one record that gets returned to determine the data and pull out each of those values for the fields that have been returned. Now, in this case, we're using the database.query. That allows us to pass in a string, which, that's how we get things to be dynamic, is because now we've passed in the string and it can actually query for it. And it's crazy because the database.query happens in a different sequence in the compiler than when you were doing your square bracket select statements. I think those actually happen previous to being compiled, as opposed to these, which happen post-compiling. I'm not exactly sure which order it is. My co-host RJ does, and I think he even spoke about it on one of our previous episodes. But it was interesting because we were getting limitations when we ran it one way versus the other because of the time at which it compiled. So just a little bit of cool stuff. All right, so now inside of our initial for loop, what we're going to do is we're going to grab a big chunk of code here and we'll walk over that. That'll have to do. All right. So once again, our first for loop was actually going to be querying the initial record. Now, one of the importances of actually querying in a loop when you're querying even against a single record, and especially when you're querying against a single record, is that you are returning a list regardless, okay? And so if there's no records, then you're not going to get a list index out of bounds issue because you're trying to get something that just doesn't exist. If there's more than one record, at least this way it'll iterate over both of them and just do a reassignment. But this way you're not handling issues where, what happens when there's two of them all of a sudden, right? So for loop can kind of take care of that right off the bat. And the reason why it's nice to query inside that for loop is to avoid things like heap size, where now if you were to query and put this directly into a list, that list is going to sit on your heap until it's cleared out. And that could affect you later, depending on how big your process is and how much data you're actually manipulating on your page. So doing it directly in a loop allows you to access that data right away, and then it clears it from the cache or from the heap as soon as it's over. So it's important to make sure that you try to take advantage of that when you can. The next thing we're doing is we're going to be going back to our set and going over our field names. And this is where we're actually figuring out whether or not it's an ID, in which case we don't really want it, and if it's null or if it's an empty string. Because we know that more than likely most IDs, and then by IDs I don't mean parent IDs, I just mean like our ID for this record, because we don't need it. And it's unique, so nothing else is going to match for it. But relationship IDs it will pick up. And so what we're going to do here is for each of our fields, we need to do a get describe on that. Once we've done that, we can then actually take that information and start doing stuff with it. Okay, and once again, we do want to make sure that we have a failsafe. If our field in our field name doesn't pass the initial criteria, we're going to want to get it out of our set. And the reason for that is because if we're not going to use it, why keep it, right? Because it's just going to cause headaches later when it's doing things that you don't want it to do because it shouldn't be there. All right, so the next set of conditionals after the ID is we need to determine if it's a filterable field. All right, because not all fields in Salesforce are like long text areas, rich text areas, addresses. Even though the certain parts of the addresses could be filtered, we don't really always know. We only know on specific objects which fields those even are, right? It's going to be our leads, it's going to be our accounts. We know that those have account billing and, or billing state and shipping state, but the rest of the objects don't. So we can't guarantee that that's always going to be the case. And we can't always guarantee that it's going to be populated. So we don't want to filter off a field that comes back as an address, right? Because that's one of those things where in the metadata, it's going to come back as billing address, right? It's not going to come, like, you can describe the actual individual fields in there, but initially it's going to, when it gets to that field, it might break because of the fact that it can't be used in a query as a filter. So we're going to want to make sure that we're removing those. We're going to make sure that we're removing text areas. I'm checking for IDs again, just to make sure that it's, dumped for me. And then the other things that I'm checking on the fields as they come across, since we've already got our metadata for them, besides just the name and that kind of stuff, is the field creatable, right? Is this something that I'd want to see? Because if I have no use case over, if I can't make the field populated, like things like created by ID or created by date, last modified by ID, those are things I might not have any interest in seeing, right? They might not be relevant to me. And in my case, I said, I'm going to get rid of them. The second thing we're doing is accessible. For the current logged in user, is this a field they're even allowed to see? If not, they shouldn't see it. So let's get rid of that one. If they are, cool, we'll leave that one in. And the same thing, once again, DFR is filtered or is filterable, just to check to make sure that we're not missing anything and that it can be it'll be safe for our SQL query when we build it out. Obviously, if it doesn't pass, we're going to do the same thing again down here, which was just to remove them from our list or our set. Okay, so now we're going to be building our actual query out. But before we do that, we need to figure out, once again, what the data types are so that we can manipulate them should we need to. In order to do that, we're going to figure out what the SOAP type is. And you'll notice that there's different types of, there's actually different get types in the metadata that gets returned. We want the SOAP type because that's going to actually tell us what Salesforce's vision of that field is versus just saying it's a double, right? Because it's great if it's a double, but is it a currency? Is it a decimal? Those are things that might be important to us so that we can render these correctly and format them correctly. And so for this, what I'm doing is I'm going through and I'm getting the actual SOAP type from up here. And then what I'm going to do is first determine if our query string, and this is going to be the number of fields or the fields that we're using. I only want to return 10 fields. That's the limit to how much data I really want to return, because any more than that, if you're filtering on more than that, you're going to start running into issues with SQL limitations because you can only have so many filters in a SQL query. And the length of the query string itself also needs to come into play because there's a limit to that. Massive limit, but it's a limit nonetheless. So less data typically means more, I think, than more data. So I'm going to limit mine to 10. If you're using a field set, this is where you would manipulate that information because you might not need to do a lot of this other stuff. You just get the describe information for your field set. The next thing we're doing is, as we said before, we're going to be checking our non-formatted set to determine if it contains this SOAP type. If it does, we need to handle that. If it doesn't, we're going to move on. In our case, if it does, then we are going to create or add in our formatted field names. What we're going to do is we're going to take that field name and just put the format command right around it for our SQL query. And what that does is it converts whatever the value is in there, such as a date time, a date, currency, double. It takes that and it converts it to a readable string. Okay, so if it's a currency field, it's going to append your currency tag to the front of it or prepend it. It's going to put your commas in where they need to be and your decimal points where they need to be. So that's the downside to doing this is you can't you have to convert it back if you want to actually do it for any sort of aggregation, sum, or any information like that, or you might need to alias it and query it twice.
And works with the user settings too, right?
Correct. And that's exactly correct, because it pulls down your locale and it makes sure that, like, this is how you want to read it in your time zone and everything like that, versus just coming down and either being in UTC time and you're having to convert that, or having to post convert it where you're doing string.value of and all these other kind of crazy commands. This way, since we're not going to be doing anything with the data, we don't need to aggregate it or anything like that. We just want it as a string. So we're going to go ahead and format that now. So when it comes back, it's much easier to handle for us. If we don't need to format it, we can just go ahead and add it directly into our formatted field names set, and that's good to go. The next thing that we're going to be doing is also adding the same we're going to be adding the same thing to our like-kind query string. That may be a typo, but we're going to get to that and find out. Something. All right.
Okay. We knew it was new.
So once we have all this, I want to make sure I put this in the right spot here. Cool, just over the break. All right, so that big map that we created before, the map of a string of a map of a string object, this is where we're going to start populating it. All right, and the first thing that we need to do is, for each of our field names that comes through, we're going to want to create a place to hold that information once it's been queried, and so that we can aggregate it later if we want to. And to do that, for each one of them, we're going to create a new map where the keyword is going to be the field name, and that'll be the API name of the field. And we're also going to be instantiating a new map of strings, and we're going to set some values, keys for that initially with some values. One is going to be the field label, which we're going to use our schema class in order to pull down and get the label for that field the way that you've typed it in. And then we're also going to need to get the actual field value of the field, which is what we're going to be comparing against in order to aggregate it. So this is our initial field, what that value is, and then we're going to set a count to 0, which we will then aggregate later, depending on if we have other fields that match that data. All right, so now this is the point where we're going to kind of actually start running our queries. So we're building a try-catch block. I try to avoid using too many try-catch blocks. I kind of feel it's like the last step of the puzzle, and you should, if you handled your returns and everything correctly, a lot of times you don't need it because you figured out what you're going to do with it so that your user actually gets some relevant information as to why they errored out, versus the try-catch, which, you can send back a message, you can send back a line number, but that might not even be for the right class. You could send back the stack trace, but like even that can be kind of confusing to somebody who's not familiar with it whatsoever. So if you're handling it, and especially as an ISV, you have to kind of constantly make sure that you're handling it correctly so that your user really understands why that your piece of software didn't work the way it was supposed to, right? So to do that, we've started with our try catch, and we're just, simple exception, you get message, you get line number, and we'll debug that if we have it. And then this is our actual string where we're gonna be doing all of our filters. All right, okay, so that was the reason for the like-kind query string. I knew it. So you've noticed that we have two different groupings now. Okay, we've got our like-kind query string as well as our formatted field names. The formatted field names is what we're going to be putting in here so that we can actually get that string-based results from the other records. Once again, we're doing it from our record object that we initially passed in, and then from the record ID, where in this case it doesn't equal that record ID because we don't need that record anymore, and we would hate for it to muddle up our results when if there was 0, it would always say 1 all of a sudden because it always matches itself basically. So we're going to remove that from the puzzle, and we're going to take our like kind query string, which we had built previously as we were looping through and formatting the field names, is what we're going to be joining here, and we're going to be joining it on space or space. And that's because we don't want to limit it to ands, otherwise nothing will get returned. It'll never always match everything. And so we're going to be doing a concatenation of or between everything. So it'll get all the results. And in my situation, I'm limiting it to 50,000. I don't have 50,000 records, it's my dev org, but typically in a read-only setting, you're only going to get 50,000 results anyway. And any more than that, it becomes, you know, quite laborious, and you're going to start running into all sorts of fun with the limits class. That's another topic though. Oh. Limits class, if you're not using it though, by the way, use the limits class. Okay. So we created this for loop, once again, the same way that we did previously, where we passed in our query string, and we're just going to loop over the returned records. In this case, we're hoping for many more than just one, and we're going to do stuff with all of them if we can, but we're doing it the same way where we are just doing a database.query and passing it in a string. Then what we're going to do is loop over our field names, once again, the ones that we returned previously, in order to actually get the data back from it. And since we've limited it to 10, and we've removed all the ones that we don't care about, we're only going to get the list has gotten quite a bit shorter, right? Then what we're doing is we're first going to be checking to make sure that our map even contains that key. All right, because we don't, if it's not one of the keys that we've chosen to be part of our field set or our fields that are being displayed, then once again, we don't want to do anything with it. But if it is in our map, because we set that up previously and kind of blocked out a spot for every single one of our fields that we're looking for, it's going to take that, and what it needs to do is you actually have to create a brand new map for it in order to hold the map, the piece of data that you're getting, because you can't actually aggregate anything inside your map. It's really hard to like reassign a value. You can't just do like 0 plus plus. So you actually have to get the value and then create a new basic block for it, and then you just kind of push it on over the one that was initially there. And that's what we're doing here. We've created or instantiated a new map called field info, and we are getting our function, our field name from there. And we're going to get the value of that field. And this is something that in a schema class you have to use in order to return values from S objects, generic S objects, is the get command, where you pass it your field info, in our case, is the info that we've got from our map. And we're going to do .get field value. So basically working inside of the schema class works the exact same as working inside of a map. So the commands should all be very familiar to you if you're doing a lot of that stuff already. And we are going to get our count from that map. In this case, every single time it's initially ran, they're all going to be zeros, right? And then over our count, we are going to push our brand new variable +1, right? And our brand new variable is just assigned to whatever that count was initially. But like I said, I can't just aggregate that with record count.get, .put, count, right? Unfortunately, it won't work in Salesforce, so we have to do it this way. But now we're aggregating every single time. All right, so finally we're going to get the return here. And our return, we're returning a string, as we already know. So we can go ahead and just comment this out. Place it right above it. And what we're doing here now is we are getting all of our information. Okay, we're going to get that label for the object that we passed in originally when we first set that up right at the very top of the page. We're going to get the name of the S object that we passed in originally, and that's for, I don't know why I did that. Nonetheless, it's the API name of our object. We're also getting our field data, which is all the field names that we had originally set up. Oh, the S object is because we're looping over it and it needs it to understand it. That makes sense. And then we're also getting our map, which is the record count. okay? And so all that information we're going to put inside of its own little map here, and we're just going to call json.serialize. And all that does is you can take a list, you can take a map, you can take pretty much any kind of object and run it through json.serialize, and it will create an entire JSON string. This is fantastic for Lightning because Lightning needs this, right? And JavaScript loves JSON, right? That's the way we like our data, not in XML, we like it in JSON. So that's what we're doing here. We're going to pass this right back to our JavaScript controller in a JSON format, making it a lot easier to manipulate on our page. Which brings us to our next part, because we're done with our class. So we can finally move into our Lightning component. For that, I'm going to use the developer console. Oh, I mean, yeah, you guys can totally interrupt me with questions if you need. Does anyone have any questions so far?
So this one, just one class?
Mhm.
For your demo?
Yep,
That's only one class?
it's only one class, and then we're going to build out our Lightning component.
You already switched the two Lightnings and everything. Yeah.
Oh, right.
Is that prerequisite?
What's that?
So what's the prerequisite for this class to be the environment? You say we have to be in aligning.
Oh yeah, you have to have your Lightning experience set up and enabled along with your domain so that you can actually have it available as an admin to drag into your page, because your custom components won't be available to you. I don't think any Lightning components are actually available to you until you
have the Lightning experience enabled.
Enabled, your domain enabled, and your domain deployed to your users. Yes.
Do you have a final version of this? It's kind of a cut and pasting exercise.
Oh, well.
I wonder if you have a final, in case you want to actually run our component and actually have a working controller.
Mm-hmm. Well, this is working. So like at the end of this will totally be working.
No, but I mean for us.
Oh yeah, the blog
I
is.
think the problem is with the cut and pasting, you got, I got a curly bracket missing somewhere, so I can't compile.
Yeah, so we're like following along.
Oh, I gotcha.
And so if we had like one we could cut and paste the whole code at once,
Mhm.
it would save us from.
I can definitely append that to this blog.
Yeah, append it this way.
At the like right after this, I'll make sure that this actually has. I'll give it to you, and you can make sure that the whole project is on there.
Yeah, makes sense, yeah, so that there's just one block instead of.
Yeah, because with all the dropping in and the
Yeah.
bracket, somewhere I got off, so I have either one extra or one less curly bracket, so I can't compile.
I gotcha. Okay, yeah, I will definitely make sure to
Like mixed quotes in there too. So.
Yeah,
Yeah.
Yeah.
and the formatting is, well, yeah.
Oh yeah, this was actually because everything originally was written in a different blog, the one that I'm actually like reading through right now, and then this was kind of a last minute.
Well, no, I mean, this is how we were trying to share it with you, but then if the format. Hello, by the way, I'm Christy Guzman. I'm the admin at MFAnything that helps Brian get in front of you, but don't understand exactly what he's talking about all the time. So we got it on the hands-on training so we could get it accessible to you, but some of the spacing may not come across. So, but I have access to edit this, so we definitely can. This is our first adventure with it, so we definitely can. As an admin, I like having the end result that I can copy and paste in case I mess it up along the way. So
I'll definitely make sure that that's available. All right, so moving on to our actual Lightning component. The first thing that we're going to do is actually create one. So for that, we're just going to go to new Lightning component, and I'm going to call this LikeKind 3. And if you want this available for your record pages, if you want this available for your object pages, your communities, and all that kind of stuff, you can go ahead and click all these checkboxes right away. And that way you don't have to go ahead and hard type all these implements. It'll do it for you. That's kind of the first initial piece there, is just setting up your actual component right off the bat. The next thing we're going to do is start handing it in our handlers and our attributes, as well as building our table out. for the data that's going to get displayed. It's a great chance to use Lightning Design System if you haven't already, because it'll make it look really nice. I don't think I really did in this case, but normally it looks really, really nice. So for our Aura handler, we're just going to use the one that kind of starts up initially. It's called My Action. It's the default JavaScript controller that pops up when you first launch a new Lightning component. So I didn't change that at all, but I did call it in my init. And what this does is basically just says, hey, my page is loaded, or this component has loaded. Go ahead and just start making action happen now. I don't need anything else from you or the user at this point. And we've also gone out and, once again, because we've got the has record ID and has S-object name, that's what we're able to pass into our backend controller in the Apex to determine the stuff. And so we don't actually have to write any extra code to do that. It's already there because Salesforce has said, you know what, just give them this info right away. Which makes it really nice because it unlike Visual Force pages where you had to have the standard controller match the actual object that the page is being viewed on. Otherwise, you can't view it in a record. So it is really neat about components in Lightning that you don't have to do that anymore. I'm also creating 2 variables. These are basically what's going to be coming back from my JavaScript controller when it's all done. It's going to assign my object label, the label name for the object that we're looking at, and it's going to get our record count map as a list, which is like it'll be a JSON array basically, and we'll be able to use that in or to loop over in our table. So the first thing we're doing, once again, we're going to display our label, and we're going to create a table here, and we're just using the Aura iteration component in order to loop over our record count and display the field label, the count for how many records match that field label, and the actual field value that was returned from our initial record that it's going to be matching. That's right there. That's pretty much the entire front end piece of the Lightning component. It's very light. All the work happened in the controller, and almost nothing happened on our front end. So it allows us to stay compact, right? This could get much heavier. You could have it tie in with event handlers and everything with other things across the page. But for our use case, we didn't do any of that. We're just really small. Next thing we're gonna do is create our actual controller. As I said, when this was first spun up when I created it, it just created this initial function, My Action. And so I'm gonna leave that and work with that for right now. And I'm going to create an action. And what this action is basically just assigning this variable to my method from my Apex class here. Okay, so I've got my get SObject list, which is @ enabled, okay? And also in my component, I have labeled like-kind controller 3 as my actual Apex controller. So I've tied the 2 together. It knows where to look for these @ enabled methods. You can also make an extension and it'll reach out to that as well. But that's where it's actually getting this from. And it's getting it from the component that this is assigned to, which is you've got 3 different variables that initially get passed. You don't they're all optional, but I just leave them once again because it's easier for this demo. And we're just going to go out and get an instance of the Aura enabled method that we've created in our Apex class, and we're going to set our parameters. Now the parameters names for these, they go through as a JSON object, but they need to match the parameter names of the method in Apex. Okay, so we've got 2 different parameters in here. One is rec object, one is rec ID. And so we need rec object and we need rec ID in order to pass that information forward. And SObject name and record ID are the things that we're assigning to those things. And we're getting those, once again, from our component, and those are native to the component because they come through in our implements for our actual page tag. And that's, once again, native Salesforce capability without any extra code, which is always a bonus. The next thing that we're going to do is finish up the controller and walk through it real quick. So we've created this action, but we haven't done anything with it. It's just sitting there in our cache until we actually are going to enqueue it or activate it, right? But first we need to tell it what to do when it comes back with the information, okay? Because otherwise it's not going to know. You're just going to run the method and it's just going to say, all right, cool. But it has no idea what to do. So what we're doing is we're going to set the callback, okay? And to do that, we're going to be returning a data variable, and that data is the entire map that we've stringified or serialized here in our backend. Okay, so we've taken that entire map, we've serialized it, it's coming back as a string, and since it's a string, we're going to need to parse it, right? So that's what we're doing right here. We're doing a JSON.parse on all of our values so that now we can actually work with it as a JSON object instead of just trying to figure out where the string does things. Once we have that, we're going to need to set our object label, which was the box that we're going to have at the top, and we're pulling that directly out of our object info, which is the parse JSON, and then we're going to create a list, and we're just looping over it and pushing all of our record counts and our object info directly into that list, which will allow us to then loop over it later in our front end, this is specifically what the record count that's being handled in the Aura iteration. That's what this is looping over. So we're going to set that variable to our front end component here, the record count, and that's what we're going to go over with this Aura iteration and pull out all the data that we're pushing into it right now. The final step being to actually enqueue the action, which is going to call the Java or call the Apex controller's Aura enabled method that we're looking for, and then do all of our magic for us. That brings it back to our front end. And then once this is saved, we can go to any object in our Salesforce org. So leads, I don't think I have anything on leads. All right, so I can just go ahead and click on any of these. And you'll notice I don't have the component here. We'll go to edit page. Down here is my lightning component, like-kind component 3, which is the one that we just developed now. And I can take this and I can just drag this right onto a lead object, which, you know, obviously I didn't program anything for a lead. I didn't hard code anything for a lead. I'm just, you know, crossing my fingers and hoping it's going to work on a lead. So we'll go ahead and we will activate that. And now here's our data. It's gone out and it's found out that, you know, we have 423 records that all have GB as their country, or 42 records with SL14DX. I don't know what that means.
That's their postal code that happens to have TX in it, like it was meant to be.
Oh, right. Oh, yeah, there's that's, yeah, crazy. Nonetheless, this component now is available to our admins from wherever they're looking at records in their org, right? And once again, we could enhance this more by, say, using the schema class with the field sets that your system admin may have set up, saying that, you know, this is the 5 or 6 fields that I really need returned, and you could create a parameter that you could then allow the system admin to drop the ID of that field set in, and it would automatically know to go get those fields and handle business that way versus, you know, this dynamicness. So that's why I don't really know how fast or slow I did that. Do I have like a lot of time?
You're halfway there.
Oh, okay. So I can take questions?
Yeah, you can do whatever you like to do.
I'm going to stop the show. And I want to say thank you to everybody who watched.